Hello my dear students, I am B S Pandey, your physics lecturer. My dear students, in series of standard 11th lecture, physics lecture, we are in lecture number 34 today. My dear students, in lecture number 33, we have started the new chapter. It was friction. All right, we have discussed about the static friction, limiting friction and kinetic friction. Okay, my dear students, today we will study few more, we will cover a few more topics in this particular chapter, that is the friction. Okay, so let's start today's lecture. It is lecture number 34. It is lecture number 34. And it is friction we are studying. My dear students, we have studied about the static friction, and what we study actually, the static friction is a self-adjustable frictional force. It will increase the applied force, the frictional force, it increases, but up to certain limit. The maximum value of that static frictional force we studied as a limiting frictional force. But this is also very interesting, my dear students. Once the body start moving over the surface, it means, suppose if a body is in a static state, if a body is kept over the surface, it means there is a friction force. We are applying applied force and it is not moving. It means there is a frictional force, and this frictional force actually we obtain due to that external force. Suppose we applied, if body start moving, it means the body just unlock their asperities locking. Okay, in last lecture, my dear students, we discussed what is the cause of frictional force. Actually, the one body, the asperities of one body which is kept over the other surface, it interlocked to each other. But after applying the force, remember the static frictional force, as you apply the force, okay, so this asperities actually unlock, but suddenly it locks again. Due to increase in applied force, after some value, it reached to the limiting value and asperities unlocked and the bodies move to each other. Actually, asperities unlocked, what does it mean? It means it overcome to the surface, start moving. All right, but you know that once this body moves, we have to apply the maximum force to unlock this asperities, but after this unlocking, we don't require very much force to just make this body in motion. In that case, the friction decreases actually. Okay, the maximum force it is to unlock and overcome over the surface. After that, that friction force decreases. Actually, when this surface are locked together, we apply the external force and opposing force, that is known as the static friction. After it overcome and reach to the maximum value to move over the surface, it is called the limiting, that is the maximum value of frictional force. But when it moves, to maintain the motion, we don't require very much force, because already the body has lost its inertia. All right, inertia of rest. That's why it moves, and little less frictional force applied on the surface of the body. All right, my dear student. So from here point of view, we got the very important thing. The frictional force, that is the static frictional force, increases with applied external force. All right, and it reaches to the maximum value, it is the limiting value. But after the body starts moving, this value decreases and it remains constant as it is moving. So we can plot a graph of frictional force and applied force. Remember students, we can plot a graph of frictional force and applied force here, which is not very difficult to understand. Look at here, my dear students. This is the graph of frictional force, Fr. It will be considered in Newton, and here applied force, that is the F external. You can see this will be considered in Newton as well. All right. Now, if this is the body, we are going to apply here the external force, and we are drawing here the graph for this situation. Alright. Due to this parodies of this body, remember, we are applying, and here the static is 1. We applied here the force, alright, 1 Newton, then frictional force, it is 1 Newton. We increase, it is 2 Newton. It is self-adjustable. We know that the static frictional force is the self-adjustable force. It becomes 2 Newton. We know that the maximum force it can oppose, it is, suppose it is the 10 Newton. Alright. So increasing this value linearly, 3 Newton, it becomes 3 Newton. 4 Newton, it becomes 4 Newton. So what you are getting actually, as you are increasing the external force, the frictional force, it is increasing. But if it is increasing in this way, remember, from here to here, this is the static frictional force. Alright, we can write the FRS. It is the static frictional force. But remember, my dear students, it reached to certain value. Alright, it is the static frictional force. It reached to the certain value, and the body, that is the locking, interlocking, are removed now. So this is the maximum value. Now if we'll apply the force to make the body in motion, what I told you, my dear students, we don't require very much force and the frictional force will reduce. So it reached to the maximum value. Of course, each point will give you the static frictional force. Remember, because the static frictional force is not constant. So each point will give you the static frictional force. But this is the maximum value, and this maximum value will be the limiting frictional force. So we can write this is the FR limiting. Now, you know that now body is in motional state, and in that motional state the frictional force little bit decreases. As you are increasing the external force and it is moving, of course the motion, it is increasing, the velocity, acceleration, it is increasing, but the frictional force, that is the kinetic frictional force, is being reduced. This is the static frictional force from here to here, and this is the limiting frictional force. After that, this value is being decreased, okay, and then it goes to the, it never increases, because if you increase the external force, the frictional force doesn't change, alright, and it goes in this way. Alright, it is like a constant value. As you are increasing the external force, but you can see this graph is not going up. Why? Because it attained already the maximum value. This is the maximum value and this is the limiting friction. Okay, my dear son, I hope you understand this graph very easily. This is the static frictional force. This is the maximum, that is the limiting, and after the body reaches to its motion, so the friction force decreases and it does not require any other, or does not apply any external force, extra external force. That's why we can say the friction force now, it is constant. Okay, my dear students. Okay, so I hope you got this graph clearly. My dear students, what we have studied, the formula for the friction force. Let me discuss over here. If this is the body, let me recall you. If this is the body, it is kept over the surface, external force applied, of course it is the normal, and this is the weight of the body if its mass is m. Alright, the coefficient of friction for the surface, actually we study, suppose it is mu. And what is mu? We know that mu is not the property or the value for any one surface. It is the relative value. That is, we study, if we keep this particular body over the surface, the mu is, suppose it is 0.1. Might be this will change. If we will put any other body, it might be this mu becomes 0.2 or 0.3. So remember, my dear students, this is the relative value. Alright, but anyway, we have discussed the formula for the friction force. If this body tends to move, then this friction force, it is mu times n. Alright, don't be confused. This is a very simple formula. It is mu times n. Remember, it is not the mu mg always, but it is mu times n. Now, we will discuss few questions, and then after we will move to the angle of friction and angle of repose. Okay, so let me solve few numerical questions. That is very simple. Now the value of, my dear students, mu, we know that the minimum value should be 0. Alright, minimum value should be 0. Okay. Minimum value may be 0. Here the question. Let me go for this question. A very simple question, my dear students, I'm giving. If 10 Newton of force it is acting, and here the coefficient of friction for this surface, it is given mu, it is 1 by 3. Alright, it is 1 by 3. We have to find, if we are applying here the force, mass, take the value of mass m as 10 kg. Alright, find acceleration. We have to find acceleration. In the question, we are required to find the acceleration of the body. Now, my dear students, look at here. We will apply the Newton first, second laws here again in this unit, that is the friction. What we know, my dear students, we know that if we are required to find the acceleration, first we can use our IQ to find whether this body will move or not. Alright, how much maximum force this body will apply to make this is in a static state? How much maximum force? Alright, what should be the limiting value or the frictional force that we require to unlock the asperity, that is the interlocking. Alright, to break the interlocking. So we can say here the frictional force, of course, it will act opposite to the motion or pretending motion. Here Fr, my dear students, we can write here the mu n. Let me find out the value of n. It is n, and this is the mg. Alright, so n is equals to mg, which is 10 times 10, it is 100 Newton. Alright, yes, it is 100 Newton. Now frictional force, it is mu times n, that is 1 over 3, and it is 100 Newton, it is 100 by 3, that is 33.3 Newton. Now, my dear students, you can see here, you can see the maximum force this surface and body can put 33.3 Newton. Whether this 10 Newton is sufficient to pull the body, whether this 10 Newton is capable to move the body, answer is no. So the acceleration will be how much? It is 0. This is our answer. Alright, so in this way you have to first check whether this body is moving or not. My dear students, if you are not very much capable to think over how to just find whether this body is moving or not, what you will do, you will apply here the Newton's laws of motion, and you will write 10 Newton minus Fr is equals to ma, and you will get the acceleration. You will get the acceleration. Remember, you will not get the acceleration as 0. You will get the acceleration negative value, and then you will say, yes, this body start moving in this direction. How is it possible, my dear students? Remember, the static frictional force is that frictional force, it is self-adjustable force. If this maximum 10 Newton is acting over the body, this will apply only the 10 Newton. Remember, to stop the body. It will not apply 10.1 even. It will apply 10 Newton to stop the body. Remember, this body will not move. But here this concept, what we got actually, it can apply maximum 33.3 Newton. If you are applying here the 33 Newton even, this body will not move. Remember, if you are applying 35 Newton, of course this body will move. But how much force will be there for the motion, will be responsible for the motion of this body? So this will be the 35 minus 33.3 Newton only. And due to that, the acceleration we will study. Alright. So now the next question, my dear students. Think over this question I'm giving you. If this body, again, we are applying here the 50 Newton. Alright. And the value of mu, it is given for this surface 0.1. Remember, mu is a coefficient and it is the ratio of two forces. That's why it has no unit. Remember, mu is a number, it has no unit. You are asked to find acceleration again. What will be the acceleration of the system? The mass is 10 kg. Again, you have to find the acceleration of this body. Could you solve? If you can solve, my dear students, kindly try to. So first we will check, my dear students, whether the friction whether this 50 Newton is sufficient to move the body. All right, so this is a weight mg, this is normal reaction, and m is nothing but mg. All right, you are not required to check all the time whether this one is moving, this one is sufficient to move the body or not. In the question, if it is asking to find acceleration, might be the body will move. But in competitive exam, it might be that you are required to just use your IQ, my dear students. Here the n equals to mg, again the 100 Newton. Now friction force, it will be the mu times n, that is 100 times mu, it is 0.1, and it is 10 Newton. So opposing force is 10 Newton, my dear students. It is 10 Newton, and the forward force, it is 50 Newton. Of course, this 50 Newton is much sufficient, all right, to move the body. Now we will try to find the acceleration. All right, so look at here, I'm going to find here the acceleration. Now I hope that you can solve this question by applying the Newton's laws of motion. Look at here, my dear students. This is our body, 50 Newton in this direction, and here the friction, and after this friction, even this body is moving with an acceleration a. All right, so we are writing, and all the force we can represent, although we have calculated all the value, we are not required. So here the force which is responsible to take this body in forward direction, it is a 50 Newton. So minus Fr is equals to m times a, and it is 50 minus mu n, and we have calculated mu n how much it is, 10 Newton. So it is equals to ma, that is 10 times a, and it is 40 over 10, that is 4 meter per second square. I hope you are much clear how to find the acceleration in this case. Okay, now my dear students, I'll give you one more question to solve. Here I'll solve, don't worry, but if you are getting my points, then you can pause the video to solve the question. On the surface, the two bodies are kept. They are tied with a string. Here a force of 100 Newton applied. All right, m, and this is also m. You have to find acceleration of the system and tension in the string. You have to find tension in the string and acceleration of the system. All right, if mu is given, this is the rough surface, and mu, it is 0.1. all right, for both the bodies, mu is 0.1. Then you have to find the acceleration of the system and tension in the string. How will solve? Pause the video and try to solve the question if you can. Now look at here, my dear students, how to solve this question. Of course, there will be tension, here the weight, normal reaction, suppose N1, Mg, of course this will be also N1, but we are writing N2. Why? For your practice, my dear students. Remember, here the masses are same, that's why the normal will be same. Alright, N1 and N2 will be same, which is Mg. If M is 10 kg, in my own question I will give you the value 10 kg, then it will be how much? 100 Newton. Alright, yes. How much force? One by one we consider both the body. Suppose we are considering this body, how much force it is acting by backward direction over this one. So suppose Fr1 and here Fr2. Alright, one by one we will study both the bodies. So for this body we are having Fr1, and in this direction we are having tension, and it is moving with an acceleration a. Okay, my dear students, so we'll write T minus Fr1 is equals to ma, its mass is m. So T minus mu n1 is equals to ma. This is the equation 1. Now for the second body, in this direction we are having tension, in this direction we have Fr2, in this direction we are having a force of how much? It is 100 Newton. Alright, no more forces are acting. Here the acceleration A with which it is moving. So we can write here the 100 Newton minus T minus Fr2 is equals to ma, its mass is m. 100 Newton minus T minus mu n2 is equals to ma. Am I right, my dear students? Yes. Now, this is the equation 2. We are going to add this one. T will be cancelled out. You can see this T is cancelled out. Okay. Now we'll proceed and we'll get the acceleration. We'll get the acceleration. So it is 100 minus mu n1 and mu n2, which is both the same. So we'll multiply by 2. This one and this one. This n1 and n2 are same. So the mu n, it will be. Alright. So multiplied with 2 mu and n, it is mg, which is 100 Newton. Alright. Minus and minus. We have added here is equals to twice ma. So A will be, it is 100 minus, now look at here my dear students, it is mu n1, sorry, I think we left here to write the value of mu, it is 0.1 multiplied 0.1. Okay my dear students? Yes. So it is 100 minus 20 is equals to 20A. So A will be 80 over 20. 4 meter per second square. This is the acceleration, 4 meter per second square. You will put the value of this A in any equation. Suppose in equation 1, you will get the tension. How much tension it is? T is equals to ma plus mu times n. Alright, ma, it is m10A4 plus mu 0.1 times and it is 100. So it will be 40 plus 10, it is 50 Newton. My dear students, so 50 Newton is acting on the string. I hope you understand. Okay, kindly note down. Let me discuss another question, my dear students. Remember, my dear students, today we have solved very simple question of the frictions. Okay, from next class I will introduce few interesting questions and that will be very important for the competition also. Alright, today we have discussed very simple questions. Remember, one question I'm going to discuss over here, it is from NCERT. Alright, the one question, it is from NCERT. Here, my dear student, it is a truck. Remember, data may be changed. Alright, because I don't remember the data exactly. This is a opening truck. Alright, it is a truck. Initially, this truck is in rest. Alright, yes, this is in rest. Now, look at here, a box is kept over the truck and mass of this box is given, suppose 50 kg. Alright, this is the 50 kg. The coefficient of friction between the surface of this truck and box, it is 0.1. 0.1. Alright, and the open end is 5 meter away. I think this data will match. The 5 meter away. This box has to move 5 meter to fall down from the truck. Alright. Now, according to the question, if this truck start accelerating with 5 meter per second square, 5 meter per second square, truck starts accelerating. Okay, driver starts the truck and it moves with the 5 meter per second square. Alright, my dear students. Now, just think what will happen as the truck starts moving with this acceleration 5 meter per second square. What will happen? This box will move backward. Why? Due to which force? Due to pseudo force. Alright, and it might be the box fall down from the truck. Actually, the question, if this truck is at x equals to 0, alright, so the question is, when the box fall down from the truck, how much distance this truck has covered? You have to find this value of x. Alright, you got the question? How much distance this truck has traveled as soon as this box fall down from the truck. Now, how we will think upon this question? This is the very important question, my dear students. So, look at here. We know that on this box of mass m kg, there will be a pseudo force. And how much that pseudo force will be? Pseudo force will be mass times acceleration. Acceleration of frame, that is the acceleration of truck, and mass of the box. So ma pseudo force, it will be how much? It is mass 50 kg. We have written here 50 kg times acceleration, it is 5. It is 250 Newton. Here the 250 Newton force is acting to pull this block fall down. Now, my dear students, look at here. How much time this box will take to fall down? The truck is having the same time to move in forward direction. Okay, listen carefully again. The box having the time t second. So this truck is also having the time t second to move forward, because when truck starts, this block starts moving, sliding backward, and you have to find in meanwhile the box fall down how much distance traveled by the truck. It means this time and the time for the truck will be the same. Alright, yes. So our aim is to find the time when this block fall down. With which acceleration this block is moving to fall down from the truck? Try to find out the acceleration. And it is not the acceleration A. Remember, this is the acceleration of truck with which the force, pseudo force is acting. But there is a force which is trying to stop this box. That's why the acceleration will vary. Acceleration will change actually, not vary, but acceleration will change. Okay, if pseudo force is acting in this direction, in which direction the friction force will act? Yes, in this direction friction force will act. And due to this force and this force, body is not stopped but it is moving. Suppose the acceleration is A0. Alright, suppose this acceleration is A0. Now we have to find this actually A0. So we can write here for this box, my dear students, we can write MA minus FR is equals to MA0. Am I right? Yes. Force which is responsible to carry the box in forward direction. This is the force trying to stop this box, and this is the net force, mass times acceleration. Okay, my dear students. So we'll write here MA, and this friction force we can write here the mg, the normal direction it is n. So MA minus mu mg, it is equals to MA0. All the value we are having already. MA it is 250 Newton minus mu 0.1. mg it is, again we can write 50 into 10, that is the 500. Alright, it is 50 into A0. We have to find this A0 minus, this will be 50 A0. So A0 is, it is 200 by 50, 4 meter per second square. It means this truck is moving with an acceleration of 5 meter per second square, but this box is moving with 4 meter per second square to fall down from the truck. Now using this particular acceleration, alright, we can find the time. Actually this truck was in static state, that is in zero velocity, with zero velocity, so the velocity, initial velocity of this box will be also zero. Okay, my dear students. All right, so let me wrap this one. I hope you can remember or you have been written. All right, acceleration we are having 4. So for box, again for box we can write as equation of motion we are going to apply here, s equals to ut plus half at square, s equals to ut plus half at square. How much distance this truck has to travel? 5 meter. Ut, it will be the 0. Half a, how much? 4. T square, that we have to find. Alright, my dear students. Yes, so the t square we can write, it is 2. So 5 by 2. So t is equals to root under 5 by 2 second. Now truck is having this much time to move. In this time, how much distance traveled by the truck actually we have to obtain. Alright, now for truck we can write, for truck my dear students, we can write, yes, for truck s is equals to ut plus half at square. Again, this is 0. How much distance travel? We have to find half acceleration of the truck. How much acceleration of the truck? This truck is moving with an acceleration 5 meter per second square. So it is 5, and t square, how much time this truck having? This much time. So it is 5 by 2. T square we can put 5 by 2. Alright. Sorry. This 2, it is 25 by 4 meter. 25 by 4 meter. This much distance traveled by the truck. I hope you understand this question, my dear students. The truck traveled 24 by 4 meter. Alright. Yes. Now, let me give you some homework and conclude today's lecture. These are not very difficult question, my dear students. You can think by yourself also. So the homework, the first question. Let me give you the question of truck one. The first question of this truck. Now, mass of this box, this is the box. Mass of this box is 20 kg. This truck is moving with 2 meter per second square. Value of mu, it is 0.1 again. This distance is 10 meter. Okay, from open end the distance is 10 meter. Alright, how much distance, if it is x equals to 0 starting from rest, this truck is starting from rest, how much distance this truck will travel when meanwhile the box fall down? You have to find value of x. Meanwhile this box is fall down. Now the second question. It is m, it is 3m, m it is 10 kg. The coefficient of friction of this surface, it is given mu is equals to 0.2. Alright, you have to find acceleration and tension in a string. Okay, my dear student, two things you have to find: acceleration and the second, tension in the string. Okay, so only these two questions you have to solve. This is question for today's lecture, my dear students, lecture number 34. Okay, so see you in lecture number 35 of this friction. Okay, my dear students, thank you very much.